Okay, in this section, we move off of the unit circle and we start looking at trig values of any angle. And we have to take into account now the radius. Because we're off the unit circle, it's no longer 1. And to do that, we get sine theta is not just y, but y over r. And cosine is x over r, and then so on. We get all of our trig values. And then remember that for any theta, when we have x and y, we can also write this as x squared plus y squared is equal to r squared. Okay, so you can think of that as your Pythagorean theorem or your circle formula. They're the same thing when you look at them in different ways. So this pretty much right here gives us everything that we need to know to be able to solve these types of problems. So let's look at one. Let's say we want to find the trig values for theta, and the terminal side of theta passes through the point -3, -7. So what we need to do is we need to set up one of these triangles and then use all of this information here. So we graph -3, -7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, so there's -3, -7. And we're going to pass through that point. Okay, so that part's nothing new. You know how to graph a point, you know how to draw a line through it. And we need to set up our triangle. So we know we counted 3 to the left, that's this side. And then we counted 7 down, that's this side. And we need to find r. So we use this over here to find r. So we've got -3 squared plus -7 squared equals r squared, and we solve that. So 9 plus 49 is r squared. Okay, and when we take the square root, we get square root of 58 equals r. And of course, we're going to have to take the positive square root because r is a distance. R can never be negative. So we're always going to take the positive root for that one, which is what they're showing you over here. Okay, so our radius here, I'm just going to write it kind of next to it, is square root of 58, and that doesn't reduce. If it does reduce, then you want to try to reduce that. But that one does not. So once you set up your triangle, then you're just going to run through all of your trig values like this. So you can think of it as y over r, or remember you can think of this as opposite over hypotenuse if you think of it in terms of the triangles, the SOHCAHTOA thing. Okay, so you can think of them whichever way works better for you. So sine, we're always looking at it from the center, sine is going to be opposite over hypotenuse, or y over r, so that's going to be, sine theta is going to be -7 over square root of 58. And of course we're going to want to rationalize all these, so we're going to multiply by square root of 58 over square root of 58. And it looks messy, but it's pretty straightforward. Okay, and 7 and 58 don't reduce. If they did, then you would have to do something with that, but 7 does not go into 58. Alright, and then doing cosine. So cosine is going to be x over r, or adjacent over hypotenuse, so we've got -3 over square root of 58. And of course we rationalize it the same way. So we get -3 square root of 58 over 58. Does 3 go into 58? No, it does not. So that doesn't reduce either. Okay, and then tangent is going to be x over y, y over x, or opposite over adjacent. So that's going to be -7 over -3. So that's going to be +7 over 3. Okay, so you set up the triangle and you find your 3 trig values. And then from there, just remember the other 3 are the reciprocals. So let's go ahead and do that. So cosecant, remember, is the reciprocal of sine. It's easier to do the reciprocal before you rationalize. So let's do this. We would get square root of 58 over 7. Okay, because then we don't have to rationalize again. And then secant is the inverse of the reciprocal of cosine, and so we flip that, -58 over 3. And cotangent is the reciprocal of tangent, so that's going to be 3 over 7. Okay, so if you can set up the triangle and get the first 3, the next 3 should be pretty straightforward.